I'm CK, and today we have yet another one from Befaco out of Barcelona. This is the Voltio. This is a utility module, not going to be as sexy as a fancy filter or an oscillator, but something that I know will help me. It's a precision voltage source, so you can send out very precise voltage values out to your rig. So when you're testing a module or when you're calibrating, this will be really handy. Right now I take a DC power supply and use that to get the precise voltage values I want, but having it in a eurorack module will be nice. It's also an adder, so you can transpose voltage signals, which will be very good. And I think it's got a couple of other things, but we'll find out as we go along. And I hope you enjoy the video. Yeah, this will also probably be really good for tuning a rack full of oscillators, just to have one steady voltage source instead of having to come off a keyboard or something like that. Here we have this. Pick this up from thonk.co.uk as is usual. Assembly guide URL or QR code and a bomb QR code. The assembly guide is generally like the piece of paper, but again, it looks like they've stopped putting pieces of paper in, which is a-okay with me. Here we have the front panel, and we've got my pointy thing. Where is it? Ground some in and the two outs, so you can send something into it and have it come out when you add. And you can add by semitones. There's 0 volts. It's probably that goes to C sharp, D, D, whatever. So just use whatever bass note you have coming in, and then move it by semitones. And volts per octave, you can do two ways. You can go 0 to 10, or you can go -5 to +5, which is really nice. And that's on this range thing. I think that's a switch, and that'll be two LEDs telling you which way it is currently switched. And aluminum, ooh, look at that. Somebody either went too deep with the drill press, or they thought about countersinking these holes, which wouldn't make any sense, but these two holes are pretty rough-edged. It's unusual for Befaco. Now we'll take out the circuit board, which is both circuit boards in the same bag to start. I mean, connected to each other to start. Gosh darn it, my hat came off. Put it under the table. Get my scissors out. And we've got some surface mount ICs and some resistors. Surface mount resistors, a bunch of them already installed, probably so they can be certain that you're getting the right voltage values out of these. I can't read these chip part numbers. I'll look at that off camera. There's a good bit to put on here. Here's trimmers for offset -5 to 5, offset for 10 volts, octave changes, and semitone changes, and input gain. Then a couple of ICs, bunch of capacitors, a whole lot less resistors than usual. And also, did they do this by themselves? I think this might be a collaboration, because this is not their typical wavy line circuit board traces. So up here is how you select where there'll be a rotary encoder. Actually, it's not a rotary encoder. It looks like it's an actual switch, where you select the voltage range or voltage and then the semitone range. and then that's a pin header, and here's the switch. I guess it goes on the front here. Here's the range switch, a couple of sockets, and a couple of LEDs, and B equals 0.9167 volts, so about less than a volt. So maybe they're saying it's semitone. No, I don't know. I don't know what that means. I'll figure that out later. Looks pretty like a pretty straightforward build. Look at the bits and pieces. Another eurorack connector. I mean, a cable connector. We've got some stickers. Got all those stickers already. We've got some heatsink. They call it heatsink plaster, but it's high temp to cool off chips or have better thermal conductivity, typically between an IC or a transistor and a heatsink. So that means we've probably got some heat sinks inside. Okay, here's one of the rotary switches, and power connector and some pin headers and a shaft to go in there. Here's our passive components, diodes, LEDs, capacitors, sockets, and then the chips. Let me take a look at the integrated circuits that we're going to be adding. They are 412CNs. I know what those are. It's just slipping my mind right now. Again, I'll look at that off camera. And there's another rotary switch with another shaft. And there's the flick switch and some other mechanical components. And here's the typical Befaco disappointing knobs. I'm so disappointed. They just don't use the best knobs. These are simple press-on plastic knobs, no index screws, no flat spot for orientation, and then one little plastic cap for the switch. And I think this is my 19th or 20th Befaco panel nut wrench. I'm going to start a library to loan them out. So that's it. Looks like a pretty straightforward build. Doesn't look like it'll take too long. Probably the longest thing that will take is to get the precision on the offsets in the ranges. Now I am wondering what they want the thermal paste for, because I do not see any heat sinks in here. Unless it's in here and I can't... Nope, I don't see any heat sinks. Oh, there's two ferrite beads. That means we have to remember to save some of these diodes leads so that we can put them in the ferrite bead to put the chokes in. So that's it. I'll get the soldering iron heated up and we'll put this little fella together, and I'll look at the build guide because that'll tell me why we need some thermal paste. I looked up the chips while we were out. Where did I put them? These are high-performance, low-noise op-amps. And these are, I kind of thought that's what they'd be. These four are voltage references, precise voltage references. Now, the next thing that I looked in the build guide, and this one actually has pictures because this stuff says heatsink plaster, and that's not just a bad translation from Japanese for heatsink paste. It's actually a glue type material. What we're going to be doing, and we're going to do this as the first step in the build, is we're going to put 4 diodes across each of these voltage reference ICs. Then later we're going to put this all over them. It's a heatsink glue, not just the paste that I usually use, which is not glue, it's just for thermal transfer. And then this piece of IC material is actually the heat sink. We're going to be, after we break this out, we're going to be gluing that on top of this whole set of ICs plus diodes, because this, as you may be able to tell, it's plated, it's solid copper there, like you might find on the ground plane, like this part of the IC. So that's interesting. Now, they don't talk about breaking the boards apart, but I like to break the boards apart before I start working. It's just, it's better for my mind. And that's done. Throw the extras, throw the sprues in the garbage. Do not throw this away, because that is our heat sink, or heat stabilizing area. I think that's what it's all about. I think we want the diodes and the ICs at a consistent temperature. And I'll show you the pictures when we get back into that area. So let me get all the 4148 diodes out and make sure this little capacitor doesn't come along for the ride. And I'm going to scroll down through the instructions so you can see they're very, very specific here. Here's the line drawing, and you can see we're going to have it about like so, and the black stripe on the diodes is going to go to the square holes. Then after we do all that, we're going to be spreading this goop all over it, pressing it down, trimming the edges after it hardens. So that will be after we have everything else. Now, the other thing we're going to do, as I mentioned, since we've got two ferrite cores that we're going to be using to condition the power down by the power connector down here. But first I'm going to get all these diodes out. So we're not going to have resistor time tonight. However, we are going to have diode time. So let's see how we have to place these, because I don't think we want the legs all the way squished up against the body. No, we do not. We want about 1 millimeter on each side, and they're very, very insistent that you want to make sure these diodes are as flat as possible on top of the ICs. So I'm going to put these 4 on. And I'm going to lean on the board with my pinky finger here to make sure I'm as flat as I can be. I'm getting the diodes as flat as they can be. So now I'm going to do the rest of these diodes. So diode time is over for today. Let me zoom in a little closer here just for a little bit. And you can see all 4 of the ICs are covered with diodes. There are 2 more 4148s down here, and then our regular power protection diodes, the big black ones, are down there. Next, we'll put the ferrite beads on, and as I said, they go down here where the marked with an F. I'm going to back the camera up again a little bit. So we grab a ferrite bead right there. And then we take one of our diode leads, put the ferrite bead on it, bend the lead down, just like you would a resistor or a capacitor or whatever. And then put it right through. These are not polarized, they're just hunks of ferrite formed into cylinders. We'll do both of them. Now we're going to do the IC sockets. They're both the same because both the op amps are the same. And they go down here, and there's a notch on the socket which matches the notch on the printed circuit board, which will match the notch. Is it a notch or a dot? Or the dot on the IC. Now that leg is a little bent. That leg's all snaggled out. Take my needle nose pliers, get them all parallel again. And since I took it off the board, I'm going to double check I've got the notch correct again, and it is. Now we'll flip it over. Level it out. Do one leg on each IC socket. Come on. Let it cool. Flip it over, take a look, make sure it's completely flat to the board. And it is, so I can do all those pins. And next we're going to do all the decoupling caps, the 104s, the 100 nanofarad. And then we've got 2 1 nanofarads. There's the capacitors. Now I want us to put the pin headers on. So they want us to put the pin headers on this board too. You can tell if it's right because there's a hole. Let's get something thinner. Use a solder. There's a hole here for a spacer, and that matches. Now I'll pull these back apart. I'm double checking all those connections. They all look good. Set that aside for now. Next will be the power connector. Now we'll do the trimmers. I think they're all the same. They're all 10K, I think. 103, 103, 103, 103, and 103. So that's a 10 with 3 zeros after it, which is 10,000 ohms, 10K. Now we'll put the 2 ICs on. Bending the legs up against my workbench a little bit. Making sure I've got the dot where it's supposed to be. Meaning that the dot goes on the notch end of the socket and the outline printed on the circuit board. And they're all good. Okay, so that is this board done. And that'll be it for this evening, because the cats are scratching at the door saying, "Where are our minnows?" Now we start working on the front panel. Or I mean the control panel. And we're going to put the 2 rotary switches on first. And what is important to note... Oops, wait a minute. I'm sorry. I neglected to put 2 capacitors on here. I saw them lying around in here and saying, what the hey? These are the smoothing capacitors for the power. I think they're both the same. They're both 10 nano at 35 volts. Okay, back to what I was saying. You got to be careful with these two rotary switches. One has 12 pins, one has 11 pins. And they have a little index pin. I think you can see it on the circuit board. There's an index pin there, so you don't have to worry about worrying about exactly how it goes on. The index pin will guide you. Why is the index? Of course, you got to get the thing rotated in the right direction. We'll put this toggle switch in. I think this will be a tight fit. Nope, it's a sloppy fit. It's a sloppy fit. Now the jacks. Now they're saying screw the banana connectors to the panel. We're not going to put them on the board. I'm sorry, I was wrong. I thought they were telling us to put them on there, and I wouldn't have wanted to do that because that would be bad. And they're good. We're not doing any soldering on those, just like everything else. We're not soldering yet, and we've got 2 LEDs to drop in. Okay, I'm trying to see when they tell us to actually do the gluing up. Oh, we didn't put the spacers on. I'll put the spacer on here in just a second. Where are the screws? Not those screws. Where are the screws for the spacers? Oh, they want us to do it that way. Really? Are you sure? The text says secure the spacer on the control PCB through the hole with the silver outline, the main body of the spacer on the component side and the nut on the mechanical side. Oh, okay, I guess that's the way you could look at that. Okay. I'm still looking for the screw though. There it is. I think we're going to be all okay with that. So now we're going to put the front panel on. And this will be a little interesting. I think we want to put the handles in the rotary switches before we put the front panel on. I think. We'll take a look here. It's also got a flat side, but I can't see. There it is. The flat side on the switch itself is a little difficult to see, but not too bad. There. That will make it work better. And don't forget the toggle switch. I'm taking a look here to see how this goes on. Okay, that looks about parallel. I'm going to measure this. 16 millimeters. Okay, good. So we're okay there. I don't like that all that much. There's a washer that you may have seen underneath that. It's a little... The panel's going to ride on it. Though we're not screwing anything on there, so it's probably not going to be too bad. But so we're basically holding the panel on with this switch. The nut on this switch will be holding the front panel on, which is a little unusual. So I'm going to put that together like so. Yeah, I'm not liking the mechanical fitment here on the 2 rotary switches. I'm going to take it off again just to take a better look at this. Yeah, that's as far down as it goes. Okay. Yeah, because again, the front panel is going to be riding on these little split washers. Yeah, it's not... Yeah, this fit is not as robust as some others we've had in the past. But we'll make do. Let me get a couple of pieces of foam here, because I'm going to do the jacks first, and I want to make sure that they're being pressed flat against the circuit board, because there's a little bit, there's like a 1.5 millimeter of slop in there, and I don't particularly care for that. I got to get something else to rest the other side of this on. I'll just hold it. I'll just hold it. It'll be fine. Just do one leg of each to start. They're fine, right? Yes, they are. Okay. Now I'm going to do the switch. And the switch, again, also needs a little foam pieces to push on the switch handle to make sure we've got the switch flat on the PCB. And I'll do one pin there. Pick it up, take a look. That looks good. I'm going to make sure the rotary switches are completely down. And there, I'm less worried about them because that little lock washer thingy is holding them in place. And that, I believe I got all the pins. The banana plug you might have seen, I put a lot of solder on there and held the iron on there for a while to make sure it heated this up enough. I'm probably never going to use those, but for completeness sake. Also be careful because there's all these surface mount resistors on the board. And if you brush those surface mount resistors on the board, then you may dislodge, with your soldering iron, you may dislodge them. That certainly can happen. Normally I do them this way, and they go through the panel, but the panel does not, the hole for this switch does not go through the panel. I mean, it's not big enough for the sleeve on this particular fitting. I think I would have done something different there. I mean, it's not going to hurt anything. It's all going to work fine, but it's not quite as elegant. Again, usually the diameter of the hole is a little bit bigger, and this sleeve portion goes through, but it's not on this one. Checking how these rotate. Rotate just fine. Very definite click when it gets to the fully counterclockwise. Alrighty, now they want to test the module before we go on to the next step. So I'll go ahead and do that. Grab my power supply. I'm going to put the boards together right now for this test only, because we've still got the glue up to do, but we're going to test it just to make sure things are... Oh, the tails of the banana plugs are hitting the power connector, so I can't put this all the way together. I'm going to go cut those off. I'm going to turn the cameras off while I do that, because I'm not going to do it on the workbench. This workbench, I'm going to do it on my other workbench. Okay, so I trimmed the ends of those off. Now we'll put the panels together again, and it should go together better. Oops, got to get all the pins in. Oh, look at that! Huh. The legs of the switches are hitting, the trimmers. Huh. Well, I'm going to have to clip those off too. I mean, that's not I can do it, it's just kind of unusual. I won't turn the cameras off this time. I'll just make a jump cut. Now it should go together. Okay, now we've got it together. That's interesting. Obviously I'm going to write to them about that. But back to what we're doing, we're going to see if we're getting any DC voltage. That's what they would like us to do now. Moving things out of the way without losing them. First test, connect ribbon cable from our little... What is that one doing there? 12 volt AC. Get it untangled from my 12 volt DC. And we'll plug that in, and maybe something will blow up. Nope, LED came on correctly with the range set at the top. That's good. And the range switch works. Now I'm gonna see what we've got power-wise coming out of here. I'm gonna go to, because that's at 0 volts, I'm gonna go to maybe 1. Where's the other end of these? Go to ground, and that's 4 volts. Let me just leave them in there for a little bit. $3 volts. Oh, because we're on plus or minus. I'm going to switch over to 0 to 1. So that's 0. It's showing a little, but not a lot. That's semitones. I'll go volts. That's 1 volt, 2 volt, 3 volt. Looks like they're all off by just a little bit. We'll trim that out later. But the basic functionality works. And that's what we were checking for. So let me unplug this. Watch this as I unplug the power supply from... You can't see it. There you can. Watch these two LEDs that my index finger is pointing to as I unplug this. It's unplugged, and it's still plugged into the module, but watch how slowly it fades away. That's what happens when you've got these 6 big smoothing capacitors in the power supply. It really takes a while for the power to drain out. So we'll put that back where that goes. We'll drag it out again when we calibrate this thing, but we're a ways away from that. Now we're going to do this special thing here. So let me get this out of the way. I'm going to set the front panel aside. Get my foam back in the place where it belongs, because we still got some glue up to do here. So let me get another thing to put on my workbench, because I don't want to get this glue all over everything. Just grabbed a scrap piece of wood to put it on top of. Then I'm also going to get something that you should have in your shop. Popsicle sticks. I'm going to be spreading this glue with popsicle sticks, and just get a box of them from Amazon or Etsy or Alibaba or wherever you buy your componentry. They're like $1 for 100 of them. Now we're going to take here, the instructions are right here, and they're too small for you to, I mean, it's too close to the camera for you to see it probably clearly, but they show you exactly, golly gosh, they show you exactly what you want to be doing here. The other thing I'm going to do, because I am messy, is put a pair of gloves on, or else I'll have this thermal glue, or they call it thermoplaster, all over my hands, and then it'll get all over everywhere. Of course, first you have to be smart enough to figure out how to put the gloves on. I'm going to get a little heat sink piece ready. So we'll open this tube. It is sealed, so we'll just push the pokey thing at the end of the cap in it to break the seal open. Now, place thermal glue over the diodes above IC 1, 2, 3, and 4. Make sure it covers all the diodes and ICs. The excess of glue can be removed later, so don't be a Scrooge, is what the instructions say. So we're not going to be Scroogey. And I want to have a good base to put the heat sink on it, or heat, I don't know if I call it a heat sink, a heat smoother, I'll call it that. And there we go. And there's a little coming out the side. I'm not worried about that, because we'll trim that off once this hardens. Now they are very clear that it will take a number of hours for this to harden. So that's it for this evening. And I will do what I always do. I always put a little glob of whatever glue or sealant I'm using and put it on a popsicle stick like that. So instead of trying to poke at what I've actually been working on to see if it is hardened, which can dislodge stuff, cause other problems, I can poke at the little test sample and then to determine whether it's hardened, and I have no risk of hurting the actual product that I'm working on. Doesn't matter, but I'm getting it off that IC. I mean that capacitor. So now I have to go away, because if I don't go away, I will poke and prod at it. So I'm going to just let this harden overnight. It's been 23 hours, and if I check my test globs, they're all completely dry. It's a little resilient still, it's a little flexible, but that means this is on fine. They do mention that you can clean up the putty on the sides if you want. I don't really care. I took some off with my fingernail right there. But other than that, they do mention, except they put it at the very end, sort of the bananas, the legs of the bananas are too long, trim them before attaching the PCBs. So that's what I did last night when I cut them off. The one thing they didn't mention is the legs on that toggle switch. So that's okay. But just be aware you're going to have to cut those. Now I'm going to join the modules like so, making sure all the pins connect, and they all do, and they go flush. Now I've got that little screw on the spacer sticking out, so I'll put this little nut on it and screw that down. And I hear steps indicating I'm going to be interrupted in a second here. So there may be a camera skip coming. Now we'll put the knobs on. Yes, I did get interrupted, by the way, but I skipped the camera. And that is that. So the next thing is going to be that I'm going to plug this in, and I'm going to let it warm up for 15 minutes to make sure the calibration's really accurate. That's been 15 minutes, so it should be stabilized. You may hear a little hum in the background. That's my power supply warming up, my benchtop power supply warming up. So let's see, can I feel any heat on here? I can't. But we're going to make the assumption that it's stable, and we'll get our meter out. Make sure that's in frame. Get a trimmer adjuster screw driver. I think this will work. Let me make sure. Actually, I'm going to take this off. I tried something. It didn't work, so I'm taking it back off. And they say use the banana plug outlets for... Let's get this thing closer. Use the banana plug outlets for this, but I think that's because they don't figure most of you have a eurorack cable with the leads cut off and tinned, so I will be using that just because it's going to be a more secure connection. And I'm going to just connect up the two leads and turn the power on the meter on. That would help. And right now it's at 2.9. I'm going to take it into the middle there. Okay, so we'll go through the calibration steps. Yes, I know I have my visor on, Face ID. Just let me. Decent multimeter, blah blah blah. I think a fluke is pretty decent. Set the octave switch at the 5 or 0 volt. Set the semitone switch at C. Set the range switch to top, which is plus or minus 5. Adjust the plus 5 volt offset trimmer to 0 volts. And where is that? Plus 5, it's the top one. Again, they're very clearly labeled on the back, so you're not going to have a problem finding it. So I've got to trim out this 065. There we go. That's that one. Now we're going to offset Dev Cal. I'll set the octave switch at the 7 o'clock position, -5, and then range switch to the bottom position, which is 10 volts. So this should be 0, and that's the offset trimmer. Offset trimmer. Don't have to take much out on that. Now the octave switch calibration. Now we'll set the octave switch at 10 plus 5. That's all the way over there. And then we should get 10 volts. Measured it out. is that? It's the octave trimmer, which is right here, so we want this to be right on 10. Good. Now I'm going to womp it around. It should be evens. That's 9. That's 8. 7. You can see 1/1000th of a volt up, and barely that. Looks like 1/2,000. That's good. Now semitone switch. Set octave switch at 0, -5. Oops. Don't ground your... Try not to short out your power supply while you're doing this. Semitone switch at B, which is all the way around here. And adjust semitone for 0.9167. We're at 0.943. Semitone trimmer. So we want that to be a little bit lower. .16, 9.167, because I don't have enough decimal places on this meter. That's okay. I'm not too worried about it. I'm going to go up a hair more, since it should be, I'm right there. It's flickering between 6 and 7, so that's fine for me. Following the next table, see if we've got a table of values. So I'm going to go all the way back to C. Should be 0. It's not. I'm going to take that down to 0. Just gently, gently, gently backing it off. Now I'm not so gently backing it off. Oh, that's not going to work. Okay. I'm sorry, I got to go do this again because I was forgetting that the 0 reading is not really what I want to do the test on. So now we got to put this back up to the 9.17. Yeah, don't try to adjust at 0. Okay, I'm going to go there. That's pretty good. Again, we're right where I want to be. Hair, back it off a little bit. Here we go. Now I'm just going to go backwards. A sharp should be 8.33. And that should be 0.833. If I let it stabilize, 0.085, that's fine with me. I'm gonna live with that. Now the sum in, enter some external voltage at the in, and I will send, I'm going to send 3 volts in. They say it doesn't matter what the actual voltage in, that's not what we're caring about. This is from my DC bench top power supply where the cables are all tangled up. Why are you tangled up? How can you be tangled up? This doesn't make any sense. I don't know how I tangled this up. And we'll put this in the input, which is the sum over here. And set the semitone switch at C. Semitone at C, which is 0. disconnect the multimeter ground probe, which is this one, and put it on test point 5. So we want to measure 0 volts between, and test point 5, I just saw it, test point 5 is right here, near the trimmer, which is nice. So I'm getting, oops, the hole is big enough to let the probe go through. So that is a little high, so I'm going to back that off. That should be 0. There should be 0 between the two. And that's it. That's all the calibration. So that wasn't too bad, was it? I'm going to plug the meter back in to the output here. And take the external out and turn that off because it's making noise. Come on, come on. There we go. It'll turn itself off after it cools off. There we go. So there we have it. We have either 0 to 10 volts. Oh, that's semitone. I'm sorry, I keep moving the wrong switches. I'll get used to this once I use it. 0 to 10 volts, that's fine. Go all the way back to 0 again. It's a thousandth of a volt up, but I'm okay with that. Go back to the plus minus 5, minus 5, minus 4, 3. That got up a little high again. I'm going to take that down a fraction. And again, they do say if you go through these steps repeatedly, you'll probably get better accuracy. So that's what this does, and I'm not going to put it in the rack because it doesn't make any noise, it doesn't do anything but generate voltages. I'll be using this probably primarily on the desktop, on the benchtop here, to calibrate things, but I can also put it in the rack to do a real good fine-tuning on, like if I've got a number of oscillators that I want to work in unison, I can set it to say 2 volts and then trim all the way down to where and then go through all the note values and adjust each oscillator's tuning so they're dead on with each other. So it's a good little unit. As you saw, relatively straightforward to put together. You do have to trim the legs off of this, and you have to trim the legs off this switch, which I did not expect. But I'll send a note to Befaco so they can add that to this build guide. And that's what it does. And it's a good little unit, very, very utilitarian, but also very, very useful. And I hope you enjoyed the video.